4.1, we're going to look at the graphs of sine and cosine functions. It's going to be super, super exciting. So the trig graphs are what we call periodic functions, and what that means is that it repeats in a set pattern over and over and over again. Okay? So they have the same shape repeated over and over again. So it's sort of like this periodic graph represents a normal heartbeat. See how it repeats over and over and over again? Yeah?
Yes.
Okay. So because many things in daily life repeat with a predictable pattern, we can use trig functions to model those patterns. And so that's where the graphs of trig functions come in. And we actually use those to represent those models. So meteorologists work with trig graphs, interestingly enough. Okay, so a periodic function is a function whose y values repeat in a set pattern every so many x values. All 6 of the trig function graphs are periodic. Today we're only going to look at 2 of them. We're going to look at y equals a sine bx and y equals a cosine bx. Now, we chose sine and cosine together, first off because they are the simplest of the 6 graphs, but also because they are the only 2 that are wave graphs. So they make a wave when you graph them. So I'm going to pause for a minute, let you take a few notes, and then we'll talk about what you need to memorize and how to kind of graph these. So the first thing you need to recognize here is that the coefficient of the trig function has a name. We call it little a so that we can talk about it without always having to say the coefficient of the trig function. The coefficient of the x is called little b, and those tell you something about the graph. And so that's what we're going to do today, is start to figure out what do a and b, what effect do they have on the graph of sine and cosine. Okay? When we graph trig functions, x is the angle, like that's your domain. It represents the angle. Whereas the y value of the function is the trig function value. So it'll come from your unit circle. Sine and cosine graphs are the only 2 graphs that are waves, and the period is how long it takes on the x-axis for the y values to go through a complete cycle. We have a typo. Okay. To find the period of any sine or cosine graph, you simply take 2 pi and divide it by b. That's how you find the period, and that's the most important thing, that you can find the period. So that's the formula for it. The period of sine and cosine is 2 pi divided by b. The amplitude, because they're waves, the amplitude is how far from the center a wave stretches. And the amplitude is always a positive value, even if the a value is negative. So it's the absolute value of a. When we do start to graph, those are going to be the first things we do, is find the period and the amplitude. I have found that with trig function graphing, people do better if they have a set method. And there are several ways of graphing, and different teachers do it different ways, and if you don't like the way I do it, then you can go ask Ms. Krebs maybe to help you, if it doesn't make sense. But we can look at some other ways. But in class, here's how I'm going to do it every time. I'm going to identify the amplitude, and I'm going to find the period. And then I'm going to make a table with 5 points, an XY table, like a T-table, And I'm always going to start the first x value at 0, and the 5th x value will be my period. That way I'll see 1 full cycle, and then I can find the other 3 x values by dividing equally among them. Then we'll evaluate each of the x values into the function, find the y value, and you'll use the unit circle to do that. And the neat part is, the way this works out, the way I have the table set up, every x value ends up being not just on the unit circle, but it ends up being the quadrantals, and those are the easiest to evaluate anyway. So that's why I like this method. Then we connect the points in a smooth wave and extend over the desired number of periods. And I'll tell you, graph only 1 period, graph 2, graph 3, that kind of thing. So pay attention to directions. So the first thing we're going to do is we're going to look at what we call the parent function of sine. The parent function is simply where a and b are both 1. So we're going to look at y equals, or f of x equals 1 sine of 1x. It's just the most basic sine graph there is. And we're going to go ahead and look at it and see just the basics, and then we'll start changing the values of a and b. Okay, so the first thing we have to do for y equals 1 sine of 1x is find the amplitude and period. All right. So the amplitude is the absolute value of a. Well, what is a? 1. So the absolute value of 1 is 1. And the period is 2 pi divided by b. And in this case, b is 1. So the period is just 2 pi. And these are the easiest to do when the period is 2 pi. Then we're going to make a table of x and y values. And we're going to start that table at 0. We're going to skip 3 spaces, and we're going to end that table at whatever our period is. So our period is 2 pi. So we'll skip 3 slots. And then down here, this will be 2 pi. So it starts at 0, ends at 2 pi. There are other methods for doing this. Some people go from negative pi to pi. I find that harder. I like for my table to start at 0 because I can see the patterns better. Okay? Then we have to decide how to divide this up equally. There are a couple of methods for doing this, and I'll show you both. I just asked myself what's halfway between 0 and 2 pi. Well, that's what goes in the middle. Then I say what's halfway between 0 and pi. Pi over 2. Now, it's a little bit harder for some people to find halfway between pi and 2 pi. But we know, you should know that that one's 3 pi over 2. Another way to do that is once you establish this one right here, that's how much you go up each time. That's like called your scale. You know, so if I go to 0, I go up half pi. If I go up another half pi, I'm at pi. Another half, I'm at 1.5. And then another would be at 2. So there are all different ways to do that. Or you can just average these two together. So that's the easy part. Well, actually, that's usually the hard part for people is finding those x's. Because if you have a period of like 2 pi over 5, and then you imagine halving it and halving it again, it can get like, that's where you can bog down without a calculator. Now we have to find the y values. To find the y values, you plug into the function y equals sine of x. Okay, well the first one we're going to evaluate is sine of what? 0, the sine of 0. You should know that from your unit circle. It's the 0.10, so what's the sign?
0.
0, yeah. So that one's 0. So that's what goes here. When x is 0, y is also 0. Then we plug in, instead of 0, we're going to plug in pi over 2. Well, the sine of pi over 2 is what? 1, yeah. So this is 1. And then we'll do pi. This is the point -1, 0. And so the sign of that is 0. So it goes 0, 1, 0. What comes next? What's the sign of 3 pi over 2?
0, -1.
Yeah. If you look at that ordered pair that goes with that angle, 3 pi over 2, the sign value is -1. And then we're back over here at 2 pi, which means it's 0 again. And it would just start over if it kept going. 2 pi, 5 pi over 2, 3 pi, 7 pi over 2, all that good stuff. So it would just keep going and going. Any questions about how we filled out that table? No? You're sure?
I have not about the table, but are all of them going to be on the unit circle?
They will all, the way I have it set up and I've asked you to divide your table up, they will not only be on the unit circle, they will go back to the quadrantals every time, even if b isn't 1. So they'll always be like integers, which is nice. And you won't have to graph any square roots or square root of 3 over 2. So it's going to be okay. It's just when your brain, you'll see it in a couple of examples, you'll be like, oh, that's why it goes back to the unit circle, the quadrantals every time. May I erase some of this?
Mm-hmm.
Okay, so we're going to erase some of this, and then we're going to actually draw the graph. So there's something weird up there. We have something hidden. Let's pause and get rid of it. Okay, so here's what our graph is going to look like. Here's our x-axis, and here's our y-axis. And our y-axis doesn't need to be very tall, because what's the highest number I'm going to?
Like 1.
1 and -1. So here's 1, here's -1. And then I need to build a scale on my x-axis. So if I'm going to go from 0 to 2 pi to get 1 period, then I'll let this be 2 pi, this be pi, half pi, and 3 pi over 2. Alrighty. Then all we do is put those 5 points on the graph. So 0, 0, pi over 2, 1, 3 pi over 2, nope, just kidding, pi 0, 3 pi over 2, -1, and 2 pi. So those are our points, and then you connect them in a smooth wave shape. That is what one period of sine looks like. Then, if you're asked to graph more periods, you could either build onto this end over here and build out to 4 pi and do it again and repeat. And your book will do that sometimes. They'll give you weird pieces of the graph. Like they'll go from like 0 to 4 pi, whereas I would probably just back up and put it over here in the negatives. So that's what I'm going to do, just so you can see it done. I'm going to call this negative 2 pi, this negative pi, negative pi over 2, and negative 3 pi over 2. And then I'm just going to imagine reversing this wave. So if I start here, and I go down, up, down, and if I continued to move through, I would be at negative 1. Then it would come back up, and then it would cap out again, and then down to there. And then you can just connect it, and you would have 2 periods instead of 1. And remember that for this chapter, you are not allowed to use a calculator, so you're going to have to. When we take this test on this chapter, you won't be allowed to use a calculator. Got it? So you have to do all this by hand. So you need to learn to work with these fractions. It's going to be fun. Woohoo! Any questions about sine graph? No? Okay, so we're going to look at cosine next, and we'll go through that a little bit faster now that you've kind of figured it out. It's not very different from sine. So let's look at the parent function, y equals cosine of x.
Okay, I have a question.
Okay.
When you do like the negatives, would it always like flip the y? Like when you went from negative 3 pi over 2.
Hold on, let me pause and we'll look back at it, okay?
Okay.
Okay, so for y equals cosine of x, both a and b are 1. This is called the parent graph of all cosines. The amplitude is absolute value of 1, which is 1. And the period is 2 pi over b, which is also just 2 pi. So the parent functions both have an amplitude of 1 and a period of 2 pi. Then we're going to build our table, and it's going to look very similar to the sine table. We'll have 0, we'll skip 3 spaces, and we will end at the period, which is 2 pi. We'll divide that up like we did before, go in by halves. This is pi, this is half pi, this is 3 pi over 2. That was weird. Okay, everybody good so far? Okay, let's see if we can do this without a whole lot of drama. Well, imagine these points. If I take the cosine of 0, what is it? 1. If I take the cosine of pi over 2, is 0. If I take the cosine of pi, negative 1. And if I take the cosine of 3 pi over 2, we're back at 0. And when I hit 2 pi, I'm back at this point, so I'm back to 1. So see how easy that is to do? It's always going to be that easy, so don't get stressed out. It's not a hard thing to do without a calculator. Are we good? Okay. So if I sketch that, show you what happens here. I'll let this be 2 pi, divide it all up again. Okay, we put our points on. This is 0, 1. Now remember that sine went through the origin. It went through 0, 0, but cosine doesn't. It goes through 0, 1. Then pi over 2, pi, 3 pi over 2, and 1. So cosine's kind of funny looking if you only do 1 period. Because what it does, you see one full downward cycle of the wave, but you see that the top has been cut in half right there. But if we continue on the other side, it'll look more normal. So let's imagine that we're going to continue out the other way. We'll put negative 2 pi on and build from there. Okay, so if I imagine extending this graph over into the negatives, it's starting to come back down, so it moves through the intercept right here, and down to negative 1, back up to 0, and back up to positive 1. So the nice thing about the way that we've designed our table is every other value is 0. And that's the graph of y equals cosine of x.